Hello, is
Hello,
there
is there
anyone?
anyone?
Is
Is
anyone
anyone
here?
here?
Hello,
Hello,
hello
hello,
everyone.
everyone.
Okay, I
Okay,
can
I can
see
see
that some
that some
people are
people are
getting
getting
on
on
right
right
now,
now,
which is
which is
wonderful.
wonderful.
Can you
Can
say
you say
something in the
something in the
chat?
chat?
Hey, I'm
Hey, I'm
doing good,
doing good,
Romina.
Romina.
Thank you
Thank you
for
for
asking.
asking.
How
How
about you?
about
I
you? I
hope you
hope
had
you
a
had a
great
great
weekend.
weekend.
Okay,
Okay,
well, the
well, the
number of
number of
people
people
getting
getting
online is
online is
increasing.
increasing.
That's
That's
interesting.
interesting.
Okay,
Okay,
that's
that's
great.
great.
All
All
right.
right.
I
I
hope you
hope you
guys can
guys can
hear me
hear me
clearly.
clearly.
I'm
I'm
testing the
testing the
mic and
mic
it
and it
seems that
seems that
it's
it's
working.
working.
And I
And I
really
really
hope
hope
that you
that you
can
can
hear me
hear me
well.
well. Mm.
All right,
All right,
guys, can
guys,
you
can you
please
please
tell me in
tell
the
me in the
chat
chat
if you
if
can
you can
hear me
hear me
well?
well?
Oh,
Oh,
Chewon, how
Chairwan,
are
how
you
are you
doing?
doing?
The
The
mic
mic
is
is
echoing. You
echoing, you
say?
say?
I'm not
I'm not
really
really
sure
sure
why.
why.
Oh, maybe. Is it still the same? Are you still experiencing the same issue, Chewon? Is it still echoing for you? Again, I'm aware that there's a lag between when I say things and when you hear them. So that's why I stay silent a little bit, just for me to wait for you guys to hear what I say, and then respond. Okay, not anymore. Okay, yeah, I was actually looking at the wrong chat. Okay, sorry. Okay, guys. So let's begin. Yeah. So I know what the problem was, and I fixed it. Okay. All right. Interesting. All right, guys. So what you can see on my screen is an announcement that was made in March about dplyr 1.0.0. As you know, we have used dplyr very, very heavily for data manipulation, also known as data wrangling. Okay, we've learned the filter function, the arrange function, the mutate function. We've learned group by, summarize, case when, select, if else. Oh, actually, the if else that I showed you is in base R. That's not in dplyr, even though there's an if else function in dplyr as well. But the one that I use mostly is the base one, the base R if else function. But we have extensively used the dplyr function. Now it turns out that dplyr, is getting an update. So the package is getting an update. And what does it mean? It simply means that the package is getting more functions and more functionalities, more features. And actually, some of the functions that we've used or we've learned, okay, they have become more powerful actually in the sense that they can do more. There is a development version which is available. In other words, it's not been released yet. So if run install.packages dplyr, you're not going to get this, okay? But there are ways to get the updated version, okay? And so what I'm using right now is the updated version, the development version it's called, and I've been testing, all these new features. So at some point, we're going to have special sessions in which I am going to teach you, all the added stuff, that were brought to dplyr. It's actually very, very great. This function here, the across function, is really great, and I've been using it. We oh, no, I haven't shown you top end. I was going to show it to you last time when we had a few problems. And the summarize function has become more and more powerful. And let me just tell you this. For example, I told you that you only use the summarize function when you are trying to use many values and turn them into a single value. Like, for example, if you're trying to calculate a sum, or if you're trying to calculate an average, okay, the mean, or a standard deviation, or the minimum or the maximum, But summarize is now more powerful. Actually, you can add summaries that, you can now use summaries that are more than one value, okay, at the same time. And it's really great. So I've been testing it for the past few days. Again, I am going to teach you all this stuff when it comes out. Okay, so today, guys, as I announced on the Slack channel yesterday, today we will be learning how to merge data. This is a very important, this is a very important skill to know. Okay, how to merge different data sets. All right, so I'm going to go ahead and open up my project first. Okay. All right. Now, it is actually very, very frequent that the different data that you use for your project, for your research, for whatever you're doing with data, it is very frequent that they actually live in different tables, in different data sets. Okay. And this is actually what we've been doing, right? We have 5 data sets and they are all interrelated. Okay, they are all connected in one way or another. On one data set, you have flights data. On another data set, you have weather data. Then you have airplanes data, and they are all interrelated. Okay. So, for example, one thing that you did not know is, because I've never mentioned it, you see, when you look at the planes data set, for example, all the planes that you see listed in the planes data set, okay, not all of these planes were actually used in the flights data set, okay. Not all of them were used in the flight data set. So there are some planes that are used in there, for the different flights that you see there, but some planes are not there, you see. So it's actually important in a case like that that you learn how to merge the data set. And for a question like what is the plane that has flown the most miles, okay, or the longest in terms of time. So if you want to answer a question like that, which you will be able to after today, you will need to take the flights data set, then the planes data set, and merge them, because you have flight information on one and then you have the planes information on another, okay. And this will allow you to find what you're looking for. Yeah, okay, actually, not quite. It is true that in the flights data set you actually have tail num in there. Let me run this. I didn't want to run it because we're going to create a new script, but yeah, what I just said is not quite true, because in the flights data set, oh no, in the flights data set you have tail num, so you can actually use this column here to find the plane that has flown the most. But you can ask a question, assuming that all the flights were full, and that's an assumption. Assuming that all the flights were full, okay, all the seats were occupied, you may want to ask the question, for example, how many passengers, flew in the month of March, for example. Then you will, because the planes data set has information on the number of seats, so you will have to merge this information here with the flights information in order to sum up Okay, the number of seats for all the flights that that took place. You know, so that's an example, and of course, this we're not going to do statistics right now, but later on, I am. This is one of my plans. I want to do a statistics class using R, but we can actually study whether what do you call it? Weather conditions have had an impact on flight delays, for example. So we will use the wind speed and all that, and then we can run, some form of linear regression or anything else in order to find out whether there's a significant effect of these weather conditions variables on the flight delays, and the flight delays will be used as a dependent variable. I mean, if you didn't understand what I just said, it's perfectly fine. You don't have to. This is going to be for the next class. But again, the reason why I mentioned that is simply because I just wanted you guys to see that there are examples, or there are cases in which you need to merge data. Okay, so in the example that I just gave you, study weather conditions. I said weather twice in a row. Whether weather conditions have an impact on departure delay, or any type of delay actually. Uh, as far as flights are concerned, this is where you will get the departure delay, and this is where you get the weather conditions. So you need to merge them. Okay. Well, I used a bit of time to explain the importance of merging data, but I'm pretty sure that you guys are already aware of it. Okay, so we're not going to use the flights data set to learn because, or the any of these data sets to learn what I'm going to show you today, because they are very big. I made two smaller data sets, and we're going to use these small data sets to learn. Okay, and once we learn how to do whatever we're going to learn today on the small ones, then we can go back to the bigger data set and then test out new powers basically. Okay. All right, so now if you want to restart your R session, okay, within our studio, if you want to restart your R session, which I do very frequently, you can press Control Shift F10. So you see restarting R here, okay, and you see that my environment is now empty and the packages that are loaded have been unloaded. Hey Leonard, welcome my brother. I hope you're doing good. Okay, so everything is now fresh. So now my R session is exactly as if I had just opened our studio, basically. Okay, all right. So what I want you guys to do, because we're going to learn this thing, I would like for you guys to create a new script. So this is our first time to create a new script. You guys have been creating scripts for your homework, which is wonderful. And now we're going to create a script. Okay, yeah, and there are two ways. So it's either you click on this button here and then R script, or you can go to File, New File, R script, or Control Shift N, as you can see. All right. All right. Now, what we are going to learn now. Oh, sorry. Yeah, this is for later. So let's save this script. Let's give it a name. Okay. All right, so I just press Control S, or you can just click on the floppy disk here. Okay, and I'm going to save it right here in the project folder. Okay, in the root folder, or the root directory of our project. Let's call it joining underscore data. Okay, we're going to call it joining data, and of course it's going to be the extension is going to be .r. Okay, joining underscore data .r. Okay, now I wrote code which I'm going to share with you. Actually, I'm going to share my code, and then you will be able to copy and paste the code that's going to create the data for us. So let me go ahead and do it. All right, guys. So please check the chat. I just posted the link for the live code on the chat. Okay, and now I am going to put the code in that script, and you guys will be able to copy and paste the code. And as you can see, there's one new package which we are going to learn about, but not really today. Okay, and that's the tidyr package. So in order for all this code to work, you will need to install the tidyr package. And in order to install a package, as you guys know, you can actually do it in your console. You can go to the console very quickly, install the packages, quotes, and then tidyr like this. So I'm going to give you guys, let's say 30 seconds to go. Oops, why am I removing it? Okay, you guys can still look at it. I'm going to give you guys 30 seconds. Go ahead and please install the tidyr package. And I will explain what I'm trying to do here. And again, you already have the dplyr package. We've been using it for a long time now. So please go ahead and install tidyr now. And please let me know in the chat if you're done installing. If you completely done installing tidyr. Let me know in the chat so I'll get a sense of when people are done. Hey McNamara, welcome back. I hope you're doing good. So McNamara, okay. Oh, you said done. Okay, great. All right. So, okay, wonderful. Okay. Well, I'm going to wait. Let's say 20 more seconds. Okay, Chewon, you run the code too. Okay, that's fine. Hey, you guys can run the code as well. That's not a problem. I'll just walk you through the code very quickly, just so you understand what this code is doing, because there are functions in it that you've never really seen, especially the table function. Okay, you've not seen it, and the separate rows function. Separate rows is actually the only function we're using from the tidyr package. That's the reason why we are that's the reason why we installed that package basically. Okay, all right, so I guess I was waiting for more responses, but we still have some stealthy friends. So hopefully to these friends, I'm really hoping that you were able to install the package. Okay, all right guys, so what we did when we started working with data was to import data, but it is actually very possible to create your own data sets. The table function is one function that allows you to create your own data set. Okay, now again, as you can see, I broke lines here because I want my code to be more readable. Okay, but basically this is how the table function works. I'm going to write this here and then remove it later, but table, okay, then you specify the names of your columns. And for each column name, you specify the values that you want in that column. Let's say the first column is X, like this. All right. Because there are several columns, I'm going to use several values in the column. I'm going to use the C function, which we talked about in the past for combining values. Okay. And that's exactly what I'm doing. So I have a data set called students. I use the table function. And I have the first column called name. So as you can see here, you have the names of some students. I wonder who these guys are. Okay. And after that, you have a comma, and the comma is outside the closing parenthesis for C, and then the name of a second column, and then the values in it, and then the name of a third column, okay, and so on and so forth. All right, so let me show you C A for the first value there, B, okay, and then comma Y C 1 2. All right, so when you run this code, oh sorry, I did not load the packages. Okay, so when you run this code, see, you get a table. All right, and this is X, which is the first column, A and B, which are specified here. Then Y after the comma, Y is the name of the second column, then 1 and 2, which are the two values. Of course, these two sequences or series of values that we call vectors, actually we're going to talk about that. We're going to talk about, the base classes in R. The two vectors need to have the same length. If they are not of the same length, then you're going to get an error. And of course, all this can be stored inside a variable like I did here. Okay, so this is just a quick example or a quick explanation of what I try to do with this code. Now, let me run this. And so students and colleges are now in my environment. Now, just to show you what separate rows did, this is actually very wonderful, guys. And when we learn intermediate to advanced data manipulation, you'll see what happens here. Now, the original table, you see this pipe operator means that we are now outside the table function, right? But let me run table only. Okay, so when you run table only, you see that you have only 3 rows and then you have the 3 columns, right? And the thing is, under department, okay, you have the list of all the departments in that college, in the College of Business. By using the separate rows function, which is inside the dplyr package, it will basically create several rows such that each department will be in its own row. Okay. Hey Mary, welcome back, Mary. Hope that you're doing good. Now Mary, if you just came, then you don't have the live code. Can anyone please copy and paste the live code for Mary? Okay. All right. So the separate rows function, and this is what's going to happen. When I use it, every single department here is going to be in its own row. All right. So let me run colleges. And look at what happens now. Thank you very much, Chewon. Okay, so you see marketing, management, and economics that were on the same row, okay, here, as now they have their own row. And this is how you want your data to look like, basically. This is how you want it to look like. You don't want many different informations on the same row. You want one row for each observation, okay? One row for each piece of information, if you want. Okay, all right. So looking at the college's data set, you know that on the first row you have information on, the marketing department, which is in the College of Business, and the College of Business was created in 1920. Okay, and so on and so forth. Okay, well, I believe that looking at the data sets, it's fairly easy to know what we are trying to do here. Also, Mary, if you're trying to follow what we did, you need to install the tidyr package, because if you don't have the tidyr package, you won't be able to run this code here that has this function. Okay, so just use install.packages and then install tidyr. Okay. All right, guys. So over here you have a list of students. Okay, have a list of students, and then you have their departments. Now, this is a very special list because this is the list of the students in our school that received or who received awards, okay, from the university. So this is the list of the students. Now, guys, these numbers were randomly generated. So if you have less awards than other people, it's not really my fault, right? It is our fault. So I just randomly generated these different values. Okay. And just for the sake of knowledge, you can use the sample function to randomly generate values. So sample, okay. If you want to, randomly pick some values between 1 and 10, okay, you can just add 10 there. Now the next argument is the size argument. So how many random values do you want to pick between 1 and 10? You specify it here, 5, okay. So when you run this, okay, it will pick 5 different values between 1 and 10, okay. And there's more to that, but that's not really the goal for today. We'll learn how to use the sample. If you want to know more, please let me know, and then I will explain it to you. All right, so again, if you have more awards than others, it's not really my fault. It's the sample function that picked the number of awards for you. Okay, now we have another data set, which is colleges, which we just talked about. And here you have information on the different, departments in the school and the different colleges these departments are under, okay? So in the College of Business, you have the marketing department, you have the management department, and then you have the economics department. In the College of Science, you have the physics department, biology, and then environmental sciences. And in the engineering department, you have electrical engineering, mechanical engineering, and then civil engineering. Okay, so you have 2 different data sets. All right, now let me just put them side by side so that I can explain what I want to explain today. Okay, now let's assume, for example, that we want to find out, if you know a bit about how universities are structured, you see, every college is for the most part independent, and every college has a president, if you would, and the president, the person in charge of a college is called the dean, right? Now let's assume that the deans are trying to get some bragging rights, and they want to find out how many awards, were won by students from their own college. Okay, you see, we have some department information here, but the colleges are not there. So we will need to merge the students' data to the college's data so that we can know which college is or hosts or houses each of these departments, and then we'll be able to find out how many awards were won, okay, in each of these colleges, and to see which dean has the most bragging rights. Okay, I hope this is clear, and I'm really glad to see that we haven't really lost the connection yet. But let's hope that it continues until the end. Okay, so this is one example for merging, but there are many other cases for merging, which we're going to talk about. Now, all the functions that we're going to talk about today, guys, they are all in the dplyr package. So we're still learning data manipulation with the dplyr package. Okay, the first function, we may want to add some sections here because we are really neat people. Load packages, or you can use Control-Shift-R like I showed you last time if you want to. Okay, create data. Oh, I just mentioned it, but some of you may have forgotten. If you press Control-Shift-R, you can write the name of your section label, and then if you do, it's going to create the name of the section for you, and it's going to add a bunch of dashes for you. All right, now let's learn the different ways of joining data. The first function that we're going to learn is left join. Okay, now I'm going to show you what left join does. Now, one thing which is really important, and which I did not mention, is this. One student his name is John, okay, and John is actually a visitor, so he's not part of any of the departments that we have in the college. So let's say he comes from a different country, and he's just a visitor for, let's say, a semester or something like that. Okay, so this is something which I did not mention, and I think it's important that you guys know it for what is coming. Okay, left join. Now let's run this code. left underscore join. It is in the dplyr package, so if you load the dplyr, you have access to it. And we have to specify the names of the two data sets we're trying to join. So let's start with students. Okay, that's the first data set. And the argument for it is x. Okay, and the second argument is y. So that's the second data that we want to use for joining, like this. Okay. Now the third argument is you want to specify the name of the column that you're going to use for joining. So over here we want to join these different data sets by the department column. Okay, because we have the department column and we have another department column here, and the two columns have exactly the same values. Okay, of course there are some differences, but we want to merge by the values that are the same. Okay, now this is known as the key column. And the key column is the column that allows you to merge two data sets. So you cannot really take two completely unrelated data sets and then just merge them. I mean, it wouldn't make sense. You take a data set of, I don't know, astronauts going to the moon, and you take another data set of Olympic athletes, and you try to merge them. I mean, do they have a common column that you want to use to merge them? That's the first question. In this case, we do have one, and that's why we can use it. And it's called department, and the spelling is the same. Okay. All right, so we have to use that last argument by department. Okay. Now, this is not really needed because the spelling is the same. Okay, but I really always encourage you to still add it. Even if we didn't add it, R would have, guessed that, okay, you're trying to merge by department. So R would have guessed it, but I always encourage you to add it. It's very important. So let's run this now. I'm going to clear my console. And when we run it, lo and behold, we can see that now we have name, department, number of awards, college, okay, and year created. And you know that year created, all these are in the two different data sets, and now they have been merged. Okay, so left join allows you to do it. Okay, and this is very powerful. So if we want to find out, like I said earlier, if you want to find out the number of passengers that have been, that have traveled from New York City in the month of March 2013, you would have to merge flights and then the planes data set in order to, and that's assuming again that all flights were full. Now we have that last column here, that last row, I'm sorry, which happens to have an NA. Okay, why is that the case? Simply because the department here is called visitor. Okay, and in the college data set there's no department called visitor. All right, so in the corresponding columns of the college's data set we basically get some NAs. Okay, we basically get some NAs. So that's the explanation behind it. Okay, so let me do this again. Students, colleges, and then the left join code. All right, so I'm going to have to scroll it up and down. All right, so now this is when you want to use left join. So I'm going to briefly talk about when to use left join. Left join, okay, you see the word left here. It simply means that the priority is given to the data set on the left. So students is on the left here, colleges is on the right. So all the values on the left, in the left data set are going to stay. Like you see, join visitor, even though there was no visitor department in the data set on the right, it still remained, and all the added columns became NA. So left join, remember, it takes the left data set and tries to merge the right data set onto the left data set. Okay, that's really how you need to see this. Now we're going to try the other one. We're going to try left join, but we're going to put colleges before student. So let's copy and paste. I'm going to change colleges, students. Okay, so if we run this, it's going to take the data set on the left, which is colleges, and it's going to try to merge the right data set onto the values of colleges. But no value of colleges is going to become an NA. Okay, all the values in colleges, okay, the colleges data set are going to stay. So you see, these are the colleges, these are the departments, these are the year created. So everything stays, but now the data set on the right, which is students, now that's where you have a bunch of NAs. So why do we have NAs here? Because no student, okay, who won an award was from the management department. In the same way, no student that won an award was from the environmental science department. And that's why in these added columns here that came from the students data set, we get some NAs. And of course, the visitor, you can see that you can't even see any information on the visitor. His name was John. Okay, so because there is no match, with the visitor department, and that's not even a department, you will not even see John show up here. Okay, so the students that you see here are strictly the students whose departments are in the university. And of course, the columns of the colleges data set are given priority. I really hope that this makes sense. Okay, so basically, we have exactly the same thing with the right join function. Okay, so let's add it to the comment, left join slash right join. So they basically do the same thing, but they just give priority to one of the two. So right join is going to give priority to the data on the right. Okay, actually this is a section, so let's add the 4 dashes here. Alright, so in order to get, fairly the same data, okay, I said fairly, you will understand why I didn't say exactly the same. Left join, students was on the left, so the priority was given to students. So for right join, let's put colleges first, and let's put students on the right. So now the data here, the columns here, are going to be given priority. So let's run this. Okay, so we get exactly the same thing. The only difference is that the order of the columns changes. Okay, the order changes, and the orders. You see, that was an example. I didn't specify by department, and R told me, okay, I realized that department is the same in both data sets, so I am joining by department, even though you didn't specify it. But let's go ahead and specify. Guys, always specify the names that you want. Okay, so I'm going to run it again. All right, so the priority is given to the columns on the right. Okay, and you see John even shows up. All right, John even shows up, right? But again, all the other departments that are not represented here are not going to show up. Okay, now I'm going to run this left join and this right join. These two data set, guys, are exactly the same. Well, they are fairly similar, but in terms of values and placements of the rows and all that, they are the same. Okay, and as I said, the only difference is the columns. So because students is the first here, so names, department, and awards, and because college is the same, so it starts with college, department, and year created. Okay, but then the way it is merged is actually exactly the same. There's no difference, people. Okay, there's no difference, and the order of the rows too is different. Okay, but the content is the same. The content is the same. So this is how to use left join and right join. I am going to repeat once again. I know I repeated that a lot. If you use left join and you specify two data sets, the data on the left has the priority, and the code or the program is going to try to find if there are matching values on the data on the left and try to merge it like that. If you're using right join, then the program is going to use the data on the right, okay, and use the data on the left to try to find matching values in the data on the right. And whenever there's a matching value, it's going to create the data like that. It wouldn't be right if I didn't add the second one as well. Right join, okay. So left join had colleges on the left. Now for right join, I'm going to put colleges on the right. Okay, students, colleges by department. Okay, so these should actually be the same. Actually, guys, you know what? Let's do it like that. Let's write, the code that produces similar data together. Okay, so here for left join we put college on the left, and for right join we put college on the right. And for in the first pair, left join has students on the left and right join has students on the right. Okay, guys, so that's something that is important to know, and you may want to use it depending on what you're looking for. Next, all right. Let's look at inner join. Inner join. Okay, inner join. And just copy and paste one of them, and instead of left join, just write inner join. All right. So again, this is in the dplyr package. The first column, the first data set, students, okay, has these columns, as we know. The second one has these columns, college, department, and year created. Now, if we run this code, the first thing that I want you to realize is that there is no NA. Okay, there is no NA. So inner join basically will try to merge the data and will drop any observation for which there is no matching value. That's what inner join does. But again, it gives priority to the data on the left. Okay, this is why you see. This is actually not correct. What I said about giving priority. So you see that John, who is a visitor, is no longer shown here, is no longer in the resulting data set, but everyone else is there. Okay, and basically what you get here is the different colleges where these departments are. Okay, so you basically have a very neat data set, and you lose some values. The values that you lose are the values where there is no match, basically. And I say losing not because it's a bad thing. This is what you may be interested in doing. For example, if you want to use the example that I talked about earlier, we want to find out, the dean with the bragging rights, the dean whose college has the most awards, right? Inner join is what you want to use in a case like that, because the visitor is not part of that discussion anyway. So losing him is not a bad thing, right? I hope you understand what I mean by losing. So I wasn't saying it because it's bad. It just depends on what you're looking for. So now I'm doing inner join and colleges, and you see it's again the same thing. So all the students that won an award are there. These are the colleges and the businesses, and where you put colleges and students depends on what columns you want to show up in the first, what you want to show up first. That's basically the difference. But these two data sets are equivalent. The difference is the placement of the columns and the rows, but the content is the same. Okay, the content is the same. All right, so inner join doesn't give any priority to any data set. Okay, left join and right join instead do. Sorry. Okay, so that's inner join for you. All right. And you know what? Let's actually, let's go ahead and answer this question. So the college that got the most awards. Okay. The dean with the bragging rights is, let's write code for it. Okay. It doesn't really matter which one we pick. I'm going to pick the first one. So that's the first step. You want to merge the data set. Okay. And after merging, guys, everything else you can do. So basically, you want to find out how many awards were won for each college. Okay, so for each college, how many awards were won, right? So you can group by college and summarize using sum. Okay, so that's the first way of doing it. Or you can just use the count function and use the WT weight argument to specify n awards, just to sum up by n awards. But let's do both. So this is something that you can do from this point. So we group by college. So for each college now, summarize. Okay, n awards. Okay, so we want to sum n awards. I just gave it the same names. N awards. Let me change. Total awards, and I'm positive there's no NA here, guys. So I can just roll with this. All right. Okay, so the dean with the bragging rights is the dean of the College of Business, because 11 awards from his department, from his college. Engineering is last, actually. Hey, we can go ahead and arrange this if we want, since we're used to doing it now. Descending order, total awards. Okay, so business, science, and engineering. Okay, all right. And if you want to do it with the count function, I'm going to copy the joining step here. All right. And we want to count. Now, what do we want to count? So remember, each row here basically tells you that, okay, this college won something, okay, won some awards. So the number of times that each college shows up is the number of times, or the number of awards, okay? That's the first way to see it. But we know that that's not the case, because you see, business is showing up once here, but there are 2 awards that are won for business. So this is why you want to count by college, but you want to wait for the sum, right? You want to wait by n awards. Okay, so let's sort equals true. All right, and we get exactly the same thing. Okay, so you may want to do this or that. It really depends on you. It really depends on you. Okay, so now we know the dean with the bragging rights. Okay, let's look at the next one. We're going to talk about semi-join, and I'm looking at the chat. So if you have any question, please go ahead and ask. Okay, we're going to look at semi-join. Okay, and just like we've done before, I'm going to copy these 2 lines of code, the 2 inner joins, because it's going to be exactly the same. And I'm just going to, I was writing a French word right now. I was writing semaine, which means week in English. Okay. Week as in W-E-E-K, not W-E-A-K. Okay, week for the 7 days of the week. Okay. Now, semi means that it's not full, right? It means that it's partial in a way. So what would semi-join do? Let me run this and let me show you what it does. Okay, now this is very interesting. Now, what has been merged partially? I want you to realize here that even though we are merging the 2 data sets, okay, the columns of colleges have not been included. So you have no year created, I think it's called. You have no, let's see. Yeah, year created, okay. You don't have it there. And you have no college information. So the college is not even showing up here, okay. But what happened was simply that, okay, R took the first data set, which is students, okay, and since we are merging by departments, it looked up the departments that are here, which are also in the college's data set, and it basically filtered, okay, this data set to only keep the students whose department is also represented in colleges. That's basically what happened. So this is known as a filtering join, okay, because it's like filtering on two data sets. So you look at the departments that are in colleges and uses the departments that are in colleges to filter, the students' data set. So that's pretty neat, pretty neat. Okay, so just imagine, you have a full list of all the students, you know. Okay, I was going to use an example, I think, which will not work here. Okay, all right, so that's it. Now let's look at semi-join over here. Okay, with colleges first and students second. So you see, we don't have any student name, and things like that. We only keep the columns for colleges, right? So this is basically the colleges and the departments in which some students have won an award. Okay, so that's actually interesting. So let's assume that I am the president of the university and I just want to find out, okay, what are the departments that have students with an award? Okay, well, I can just do it. If I don't want to know who these students are. I just want to know these departments because I would like to, maybe increase the financial, whatever they are given every year, for their daily operations. Okay, I can just do it and say, okay, I need to give some money to the marketing department, the econ department, physics, biology, mechanical engineering, and so on and so forth. Okay, so yeah, that's pretty neat. So depending on what you want to do, semi-join is one thing that you may want to use. All right, guys, we have two more joins to learn today. The next one, and again, I'm still looking at the chat, and I'm not seeing any questions, so I'm really hoping that everything is good right now. I'm really hoping that you guys are learning what I'm teaching you right now. Okay, so semi-join. We have two more. We have full join. Okay. All right. So these ones are next to each other for a reason. Okay. So semi-join will only keep the columns of the first data set that you specify. But let's take a look at what full join does, guys. Full join. Okay, full join. Now, full join is basically not going to drop anything. Even if there's a mismatch, it's not going to drop anything. So check it. So this is where you get the biggest result, the biggest resulting data set actually. So check this. So all the students are here, okay, and all the departments are here as well. So everything has been joined with the corresponding NAs. Okay. So the visitor is there, but it doesn't have any college that was created in the university because it's a visitor. Now all these departments are here, but they have no student who won an award. Okay. No student and no number of awards. Okay. So everything basically has been joined, guys. Okay. So, and of course with the corresponding NAs because there's no matching values. This is something that you may want to do, who knows? If that's what you want, then there it is. Let's do the other one. The content is the same, but of course the position of the NAs and stuff like that is different because we start with the columns in colleges, college department year created, and then we merge with students. So that's why the positions are different, but the content is exactly the same. Okay, so that's full join for you. All right. Okay, guys, let's learn the last join of the day, the last joining verb in dplyr of the day, and that's anti-join. Anti-join. Okay. Again, let's just copy our code and change change full, write anti instead. All right. All right. Okay, so now anti means that, when you say antivirus, means that you're trying to kill some viruses, right? Anti anything means that you're trying to kill it, basically, right? Now let's run this. Haha. We get only one value or one row, basically. Let's run the second. We end up getting 4 rows. Okay. And the question is, what does anti-join do? Okay, I'm going to teach you what it does right now. Let me run these two first. Okay, so what happens here is actually very simple. We're trying to join by department. And the first column that we specified in the first code, at least, no. The first column is students and the second column is colleges, right? Okay, so basically what's going to happen is the code is going to look at the second data set, okay, and all the matching departments, all the departments that are also represented here are going to be taken out. Okay, that's why it's anti-join. So it looks at the second and all the same departments, okay, wherever it sees these departments here is going to take it out. This is why when I run the first code, we ended up with John only, because all these departments are here because this is the list of all departments in the school. But there's no such thing as a visitor, right? A visitor department. So because there's marketing, physics, biology, and everything else, all these are going to be taken out. Okay, so let me run it again. John, visitor, 0. Okay. Now, this is very helpful. And again, it depends on your context. It depends on what you're trying to achieve, right? This is very, very, very powerful because you may want to ask, what are who are the students who are not from the school? That could be one of your questions, right? And if you want to know who the students who are not from the schools are, well, there it is. We just found it. That's John. Okay. Now, for the second one, you may want to ask, okay, what are the departments the department in which no students got an award? Okay, maybe you're trying to help them or you want to pat them on the back, just to kind of, and not because you're proud of them, but because you want to, you want to be a comforter, basically. You want to comfort them for not getting any award or something like that. Hey, these are the people you need to go to. I mean, these are the departments you need to go to bring some comfort, I guess. Okay, so that's anti-join. Now, let me give you an example of how to use anti-join in a different context. At some point, hopefully, we get time for this. We're going to learn text analysis. How to manipulate texts and things like that, right? And in text analysis, when you take a text and you want to analyze, you want to conduct something like we call, for example, sentiment analysis. Okay, well, you want to use the words that carry some sort of emotional weight. And you see, in languages, there are many words that don't carry any meaning when they are used on their own. Like, for example, the, the, in English, or is, is does not carry any emotional meaning. Whatever follows it may carry some emotional weight, but the word is itself will not. Or an, right? So when you're doing text analysis, first you take a text, then you basically parse the text. In other words, you break the text into all the words that are used in it, okay? And because many of these words do not carry any emotional weight, if you're doing sentiment analysis, you want to remove all these words, like and the and things like that. Actually, I think I have the tidy text package. Okay, so they are called stop words. I think, text. Yeah, stop word. Let me show you. So these are some of the words that do not really carry any emotional weight. So, and there are more of them. Okay, so if you're trying to only keep the words that have the meaning that you're looking for to do some sort of analysis, you're going to use your text. So let's assume that the first data here is my text, And I'm going to anti-join with the stop words data here, okay, by word. So it's basically going to take out all the words that are here, because this is a comprehensive list. It's going to take out all the words that don't carry any weight, any emotional weight, out of my original text. And I'm going to be left with only those words that I can use to carry out sentiment analysis. Okay. Now, tidy text is very powerful, guys. If you're learning any kind of text analysis and things like that, there's actually a free book that was written by the authors of the package. And at some point, we're going to learn it, I believe. Let me see. We're going to learn some sentiment analysis at some point. So if you Google, even though I don't use Google, if you tidy text mining, okay, I just went to the link, but tidy text mining. If you just search for it, okay, it should come up as the first one. And this is going to take you to the book, actually, and it's a free book that you can have access to. Yeah, so it's a very powerful thing to know, and again, hopefully we get some time to learn it. All right, guys, let's go back to it. Okay, so and that was the last one, actually. That's anti-join. Okay, it basically takes out the values in the second data out of the first data. It basically takes out these rows, and then you're left with the ones with no match. Okay. All right, guys. So we have about 15 minutes. Let's look at some examples with our actual data set. So this script here was just meant for you to learn how to use the different joins, the joining verbs. But let's go back to our flights analysis script, and that's where we'll actually learn. That's where we will apply what we just learned. And go ahead and restart R. Let's clean up our environment. It's Control Shift F10. We did it at the beginning. Control Shift F10, and we can switch back to flight analysis. And let's go ahead and load our packages and import our data set. Oh, I didn't take the here function, so it's not going to work. Okay, so let's run everything, and let's go back to the very bottom. Okay, and in this subsection, because we're still in dplyr, right? In this subsection, okay, joining data, okay, let's say practicing joining data. Okay. All right, let's look at a few examples which are going to help us practice these things. And in your next homework, guys, once I'm done with everything I'm doing, in the new homework, you will get some questions, and hopefully they will be helpful for you. Okay. All right, let's take a look at it. Yeah, let's actually answer the first question that we asked, or one of the first questions that was asked. The question is going to be, how many passengers, okay, traveled out of NYC? How many passengers? Travel is only with a single L. Okay, traveled out of NYC. Let's do a general one. Okay, out of NYC in the year 2013. So we're basically using the entire data set. Okay, without going into some specifics, let's do this. All right, so the flights data set has what we're looking for, right? And the planes data set also has what we're looking for. Okay. Now, honestly, that's a lot of columns. So if you join these two, you're going to get a whole lot of columns, right? So we may want to, reduce them a little bit. But the first step is always to find out which column in the two data set will be the column for merging. Okay, and that's the tail num column. Tail num. So for tail num, you have that name here and you have it here as well, even though I can see the values is right here and the values are the same. So these are the IDs for every plane. So every plane has a name, and that's what tail num is. Okay, so we're trying to merge these two. And because we're only looking for how many passengers, so we want for each flight, we want to find out how many people, flew on that flight. And again, we assume that the flights were full. All right, so let's do it. We can use the pipe operator. So we really want to focus on the flights data set actually. So we're going to use left join with flights and then planes by tail num like this. Okay, so when I run this, you see now I have 22 columns instead of 14, like always. The flights data set has 14 columns, but I have 22. Everything was merged. Okay, now there's something that I want to show you here. Something that is kind of interesting that happens here. You see, we have another column here that is called year.y. The reason why we have another column that is called year.y is because the flights data, and we have year.x. The flights data has a year column, and we're not using it for merging. The planes data also has a year column, and because we specify that we want to merge by tail num and not by year, okay, so it's actually going to add the two columns in the final data set. But the thing is, because you can't really have a data set with the same name, it is possible in R, but it's not really recommended. It's going to add X for the first one and Y to the second one, just to differentiate. So this here would be year, the year column in the flights data. In the planes data, and this would be year in the flights data. Okay, so honestly, we don't really need all these columns, but what we want to do is just to we want to find how many passengers traveled out of NYC. So the number of seats here is what we want to sum up. So we don't need to group by anything here. We just want to summarize. Okay, and because it's going to sum up everything anyways. Total passengers. Okay, and this is going to be the sum of seats. And there are probably some NAs, I'm not sure. Okay, so when we run it, damn, wow, that's big. 38,851,317. Okay, this is the number of people that traveled out of New York City in 2013. Okay, as you can see, that's pretty big. That's pretty big. All right. And we can go into the details with okay, let's do it. I didn't want to do it, but let's do it. Okay, which carrier which transported the most passengers? Okay, which carrier transported the most passengers? Anything else in December? Okay, just because we want to use some of the older functions that we learned in December. Guys, I'm really hoping that you can see how much power you have right now. All the things that you can do using data. Okay, you can do a lot. All right, so we will need to do the same because we need the seats. We need the seats column from planes, and of course we need all the flights. Each row is a flight, so we need all the flights here. And this is why we left join and we use flights on the left, because we cannot afford to lose any of these rows, because each row is a flight, right? And if you want to find out how many people were transported, then you need to include all the flights, right? Actually, I am going to do something here. We will need, again, we don't really need all the columns. So what I'm going to do here is I'm going to do flights, and I'm going to reduce the number of columns. Okay, honestly, what is really needed, because we are merging, okay, we're going to use carrier because that's part of the question, and we're going to use tail num only because we're using it for merging. Okay, so we have a much smaller data set, and for the question here, We will also need month. Okay, I can put it wherever, it doesn't matter. Okay, I have to use month. If I don't use month, then I won't know, I won't be able to do to filter by December, right? Okay, so it really depends on me. I can start by filtering. So filter month equals 12. I can start with that, okay? And on that smaller data set, I can then merge. You could have merged before filtering, but filtering before merging, I think, is better for the computer, because you give less work to your computer. Instead of 330,000 or so rows, it's going to merge on only 28,000. So I think that's better from an efficiency perspective. Okay, so let's go ahead, and all this is now going to be piped into left join. Okay, and now I just need to specify the column on the right, because remember, the pipe operator is using all this and putting it as the first argument here for left join. So we're going to go ahead and specify the second argument, and that second argument is planes by till none. Even if I didn't specify, again, it wouldn't have mattered, but please specify every single time. So now we have this. Okay, and because we want which carrier transported the most passengers in December, so now we have all the flights in December's and the different planes that were used for these flights, and of course the information on these different planes and all that. Okay, so because we want it by carrier, we go to group by carrier. That's the reason why I included carrier here, because we needed to group by. But it's oh yeah, we can use the count function too. Actually, we can use the count function because it's like a group by and a sum. So let's save on the amount of typing. So we're going to count. We're doing it for each carrier, right? We're going to count carrier, okay, but it's going to be weighted by seats, because this is the number of people that were transported. All right, and of course we're going to sort, and then we get this. All right, and I can specify a name argument as well if I want. So name and passengers if you want. Okay, if you don't want the default n, you can write n passengers for number of passengers. Okay, so United Airlines is the carrier that transported the most passengers in December. The most passengers out of New York City in December. Okay, so that's what we learned, and Delta is the second one. Okay, maybe because it covers the most number of cities, I guess. Maybe. Okay. All right, so that's powerful data analysis, guys. And you can see that and you've been seeing it for a long time now. We are finding answers. We're using code to find answers, and data analysis is the process of using data to understand the world, basically, and that's what we've been doing. Oh, someone posted the live code. Can anyone please help out? I think I can actually. All right, so I just posted it for you, Leonard. Okay. All right, guys. So it's already time, but let's do one more. We're going to use an example of anti-join. So something that I told you was all the planes here. Yeah, you're welcome, Leonard. All the planes here were not necessarily used in the different flights in the flights data set, right? Okay, question. Is left join and right join opposite to each other? Yes, they are opposite in the sense that they give priority to different data. So left join will give priority to the data on the left, and right join will give priority to the data on the right. Okay, that's really what you need to remember here. Okay, so as I was saying, all the planes in the planes data set were not used. You're welcome. In the flights data set. So we want to find out what are the planes here that were not used, in 2013 to fly people out of New York City. Okay, let's assume that this is what you're looking for. Which planes were not used to fly people out of NYC. Okay. And in a case like that, you will have to use anti-join because we're trying to take some things out, right? So anti-join, and I can use the pipe operator too if I want. Oops. Okay, I can use the pipe operator, but I don't really have to. So the first data set here is going to be planes. Oh, we have a new name here, Blue Barn. I don't think I've seen you before. Well, I'm really glad to read from a new friend, I guess, and I really appreciate what you say. Thank you for the compliment. Okay, so on the left we have planes, okay, and on the right we have. Oh, again, speaking on your comment, Blue Barn, all the videos are always uploaded to YouTube. I don't know if you are in our Slack channel, but I usually post the links of the YouTube, videos once I upload them. And there's actually a playlist that I made, and I always update that playlist. So if there are videos that you haven't seen in the past, I really encourage you to take a look at them. Okay, so planes on the left. Okay, on the right we have flights, and by tail now. All right, let me explain again what's happening here. So we start with the planes dataset that you see here, right? And remember what anti-join does. It will look at the tail num column in flights, okay? And all the values that are in the tail num column in flights is going to look for them here. And whenever it sees it, it's going to take it out. So we will end up, with the planes that have not been used for the flights in the flights data set, basically. That's what's going to happen. All right, so let's take a look. Oh, guys, I was lying to you. Where did I take it from? Okay, I don't know. Where did I take this from? Okay, well, what I said was not true. All the planes in the planes data set have indeed been used. I don't know, I was teaching and I saw that it wasn't the case. All right, so let's see if all the planes used in the flights data set are reported here. Okay, now let me create an interesting context for it. Let's assume that, the Department of Aviation of the United States, I'm not sure that it even exists, has, heard a rumor that some planes have been illegally used, okay, and we assume that this is the list of all the legal planes to use for flying people, right? So you want to find out if some flights were done using planes which are not here, and that would mean that these are the illegal flights. Okay, so guys, I'm sorry, which planes were not used to fly people out of NYC? All planes were used, okay, because of course the resulting data set is an empty data set, right? Okay. Now, okay, were there illegal flights out of NYC? Okay. So basically, we're just going to change the order of the data set here. We start with flights. Okay. So flights is the first one. And the code is going to look for planes in the planes data set, look for them in the flights data set, and take them out. And whatever is left, okay, so this is where I take it from actually. Whatever is left is going to be, flights operated by planes which are not on the legal list. I hope that this context makes it more cool to write this code. Okay, we can actually take a quick look at what these planes are and what are the carriers that we are going to sanction because of the illegal flights. So carrier and tail num, of course. Okay. All right. So all these planes here are not in the legal list. And guys, again, all this is a context, right? It's not like it's illegal or anything like that. It may be that planes does not have an exhaustive list of all planes. Maybe it's an outdated list. This may be what is happening actually. Okay, not that it's legal or illegal, but hey, we need to make things cool so we can learn, right? But yeah, that's basically it. Also, this is one of the functions that I was going to teach you last time. I think did we talk about the distinct function? I I seem to remember. Maybe not. I'm not sure. But distinct is like doing group by, in the sense that it will show you the distinct or unique combinations of values. So, for example, we have AA and N3ALAA. So, when if maybe AA use this plane for other flights, it's not going to show it twice. It's only going to show this combination once. So each combination is going to be shown only once. Okay. So I'm going to use distinct carrier, and that's in the dplyr package too. Carrier and tail num. Alright. So these are the unique combinations here. So AA has this, AA has that, AA has this plane, and so on and so forth. So basically, I just wanted to find out the number of planes that each carrier has, which is not listed in the the big planes data set. So we can actually count carrier. Yeah, that's basically what we need here. We can sort equals true. The reason why we can count by carrier is because anytime a carrier shows up, it's a plane that is used, okay, by that carrier, which is not in the main list, okay, because we anti-joined here. All right. Wow. So you see, AA has 430 planes which are not on that list. Okay. MQ has 234. UA has 23, and so on and so forth. And 9E has 1. Okay. And so on and so forth. So, hey, that list needs updating because we don't have information on all these planes here. Okay. All right, guys. So this is actually what I had for you. Now, Bluebound, I'm not really sure that you are on our Slack channel. I can send you a link, an invitation link. Okay, let me look for it very quickly. But in the meantime, guys, if everything worked for you, let me go back to my code and use my other screen for this. Oh, okay. So Shewon wants me to explain the distinct function. Okay. So by distinct, what you need to understand is distinct will show you unique values. Okay, I'm going to show you something. Let's assume that okay, I'm going to use the table function which we talked about earlier, and there's going to be only one. Okay, yeah, I can use several. So A B B again A. Okay. So I'm creating a data set with the X column, and X has A, B, B, A. All right. And the Y column has, let's say, 1 for A, 2 for B, 2 for B, and 1 for A. I'm really hoping that this makes sense. DF. Okay, so all right, so this is our data set here. So we have A, B, B, A, and we have 1, 2, 2, 1. All right. Okay, so you see, we have some repeated values. Let's look at the X column only. We have some repeated values. And the repeated values, of course, are important because each row has a specific information. Okay, and again, I know that they are repeated and all that, but okay, the live code. Okay, you're asking for the live code. I have it right in front of me. I can do it. Okay, and Jody, you're asking for the pipe operator. Jody, what I'm going to do is I'm going to refer you to the video when we learned the pipe operator for the first time. So right after this, I'm going to look for where we did it, and I'm going to post it on Slack so that you can watch it, because I really explained the the theory behind it and all that. Okay, so back to this. DF pipe distinct. Now, if I use distinct with the X column only, you see, even though the values are repeated, okay, there are actually two distinct values in X, right? So if I run this, it's going to show me the unique values that we have in X. That's basically what the distinct function does. Okay, it shows the unique, the distinct values. Okay, but if I run it with more than one column, then it's going to show me the unique combinations. And actually, even though you have A1 here and A1 there, it only appears once, right? So B2, B2, well, it's the same thing. So if I run it, you see, it will show me the distinct combinations of, of the values in X and the values in Y. Okay, so even if there are repetitions like you're seeing here, the repetitions are not going to show up. It's going to show it once only. Okay, it's all clear, Chewon? Okay, I'm really glad that it is clear. And Romina was asking for the code, and I don't know, guys. You don't have access to the code. Is not live right now. The code is not working. The live code is not working. Let me check what I have here. Oh, yes, yes. Of course it's not working. I shared the first code. I never shared this one. I shared the joining data code. So let me go ahead and share this one as well, so that you guys can copy and paste. Okay. All right. Okay, so the new live code is now in the chat. All right. So the thing is, I have to share each file. I have to share each file, and you guys may have realized it, but the fact that I'm using the live code, it saves it automatically for me, because yeah, that's part of the process. So if I change my code, you see that star here, it means that the code is not saved. But if I don't do anything, it's going to save it automatically, because I'm using the live code. So it has to save it for me. The reason why I'm showing this to you is just to show you that sharing the code is script specific. So it's not like I'm sharing everything, it's script specific. All right, guys. So, okay, Chewon said it was all clear. And for Jody, I am going to send you that link so that you can watch that video again, and you have access to the playlist. And also, oh yeah, I said I was going to do it. Blue Barn, I said that I was going to send you an invitation link to our Slack channel. So if you want to join us on Slack, that's perfect. Because I share information there, we ask questions, we interact there a lot. So please join us. Okay, I'm posting the invitation link in the chat as well. That's for the Slack channel. If you're still there, Blue Bar. Alright, guys, today's session was slightly longer than usual, and I'm really glad that we didn't drop the connection today. I have not done a single thing, guys. I mean, it's not like I changed anything or something like that. I didn't do anything. Okay, and now it's working. And Chewon, you're very welcome. So, guys, if everything worked for you, please can you let us know in the chat, and then we will say goodbye. And yeah, guys, get ready. The homework for joining is going to be, fairly interesting and a little challenging, but not really. The reason why it's going to be challenging is because you don't have a lot of experience working with all these joining functions, and there are many of them. So it will take a little bit of time to kind of think. Okay, what do I want? Do I want to keep this? Do I want to keep that? Do I want to full join? Do I want to do this, that? So this is what's going to take you a bit of time, but it's not difficult. Oh yeah, Romina, it's super cool, and you're very welcome. You very, very welcome. So yeah, actually, all these functions really cover all your needs for joining dataset basically. So whatever the situation is, whatever the case is, these functions are going to cover it for you. All right, Jody, you're very welcome. Jody, really glad to see you. Really glad to see you. McNamara, you're very welcome. And Jody, I'm going to send you that link. And actually, I'm going to send you the link to the playlist so that whatever you missed, you'll be able to watch it. Okay, well, it seems that today was a was a great class. No connection drop, and you guys seem to have understood everything. That's really great, guys. I'm really glad to have spent this time with you. God bless, and let's continue our conversation on Slack. If you need anything, just reach out to me. Take care.